Well, hi, and thanks for joining me in my shop here. This is day 2 on this radio, which surprised me yesterday when I found out it works out of the box. So in the meantime, I've dusted it up a little better, taken all the dust off the speaker, and while I was poking around with it, I did notice another cracked resistor, so I'm going to show you that. But what I want to do today basically is play this radio, play all the bands, find out how well it's operating or how not well it's operating, and just kind of take stock of it before I get in there and start monkeying around with parts and whatnot. But let me show you the cracked resistor, which is really kind of hard to spot way down in there. We'll do it with the close-up camera here. I'll wait for focus. Good. Okay, of course our radio's not been switched on yet today. So I just got a glance of this. There it is, that red one. Look, see how darkened in the middle? There's a big crack through it. And the original red color on the outside here. So again, that's a coating or a covering. Because the carbon rod is conductive, and you don't want that just sitting out there. Carbon rod, I mean, like this one now has a carbon rod showing, so if you brush up against that carbon rod, I'm pretty sure you're gonna have a story to tell afterwards. But what it does show is that this heats up. It's probably a roaster. It probably heats up and gets quite warm and then sits at this warm temperature, and over a long period of time that's what's happened. We'll have to keep an eye on that. Okay. Don't think it's a serious problem. But of course, having not done any real testing of the radio yet in any serious way, I can't really know for sure. So first we're going to operate this on an antenna, which I just realized the antenna is switched to my ham gear. Oh, I had a wonderful day on ham radio yesterday. I was using FT8 for the first time. I only made a couple of contacts on it because I'm just a little new to it. I want to make sure things are working right in that, but wow, it's a totally different approach. It's pretty much almost 100% automated ham radio operation. You kind of sit and watch as your radio and computer do their thing, but it's not quite like that, but close. Okay, let's get going here. We'll flip on the radio. Just let me check the connections. Good. This is hanging in the radio. I don't want that hanging in the radio. Let's do it like that. That's better. Yeah, I was really floored when I turned this on and actually got it to work. Certainly not the first time I've taken what looks like a disaster and found out that it works. Not the first time. Or appears to work. Let's find out. Volume's down. Pretty hissy. Okay. We're on the AM band. Horrible thing here. I'm just gonna shoot a little dab of oil in there. I'll have to do something bigger with it later, but for now. Hopefully that'll make it go a little smoother. Can you see what's happening here? Hard to show you. There you can see it. Okay. Kind of get an impression of the string. It's really tough to get this on camera. See how the string is bound? Here's the thing. Can't turn it down any quieter. Shh. Oh. Well, somehow I killed it. The thing about the string binding up here, often when the first time you tune a radio, it's still in the cabinet. Maybe you're looking at it and thinking about buying it, and you're trying it out, and you're spinning the dial, and you find that it moves pretty good, pointer moves, but then it kind of gets tight all of a sudden somewhere in its range, not at the end, but somewhere in the middle, like this one has gotten tight right here. Don't force it any further. What's probably happening is the string is getting wound up on top of itself in here, and it's kind of grabbing onto itself. And you turn it further and further, the string can cut itself, or just be so tight and bound up that you're going to break it. You're just going to put too much force on an old string and break it. So these things can be sorted out. One way is to back up and come forward again and just do it again and again, and sometimes you can kind of inch your way forward to get all the way to the end if you really must. But the last thing you want to do is force it. That's just... definitely some strange stuff going on here. So I'm just testing the string out. And it's binding, through the shaft itself is binding on the thing here. A little hard to tell one from the other. There it goes, right there. It's a little bit of a different spot this time. So if you do force it, sometimes the string will correct itself, but you can see it perfectly here. Let's take a look at it. See exactly what I'm talking about here. Okay, up band. And down. Right there. See it cross? And now that cross moves down and begins to interfere with the string where it's leaving. Okay. There's a quiet spot. Yeah, the string appears to be in good shape, regardless of that. But just something to be aware of. Often has to do with the alignment of the big wheel and everything. This is loose here. Look, it's very, very loose. Worry about that later. Good to be aware of that. Hey, what about the magic eye? Let's take a look at that. Hey, I haven't got this on full power. I get too much volume already. Let's leave it on reduced power. I believe it's going to work well enough. Well, let's take a look at that magic eye. Any magic in the magic eye? I don't think there's a thing going there. Let me just turn off my lights here for a second. So you can see the red from the heater down below, but I don't see any green. Let's put the radio on full power here, because maybe this is... Here we go. Okay, so... the story there... no magic eye, but the heater is running in the tube, but there's no green whatsoever. Cannot see a thing. Okay, so let's try the band tuning across. I mean, I've done this a few times now in AM, so we'll go back down. right in the middle. This is one of those radios the dial turns the wrong way. Like the way I would tend to, I would think turning it this way, or pull the pointer this way, it goes the other way.
Promo code 640. Call 1-800-951-4758. Promo code 640. Best place you've ever had.
It's time to make a statement in the 2019 Acura MDX. Now it's up to a $3,500 cash rebate on select models. With the first ever Acura MDX Spec Sports Styling Package, you'll be turning three corners. Get lease rates from 1.9% for 36 months, or receive up to a $3,500
I can't tell which one of these is the volume and which one is the tone. I really can't tell.
For Acura GTA.ca for details. Acura. Precision crafted for...
Pretty dirty anyway. These need to be cleaned up. They're going to give me trouble down the road here. I'm working on the radio. 640. The dial is bang on. I can't believe that. It is bang on. Take a look at that. Oh. Yeah. Let's just take a look. We're listening to 640. Let me get the parallax here perfectly right here. 640. Look at that. Eh? Isn't that something? That doesn't happen too often. I was listening quietly there to hear if I can hear problems with the radio or if it's just the crummy signal on the crummy antenna. Why so quiet in there? Oh, now that's interesting. So that sounds like a signal breaking through a cutoff voltage of a tube. So we have a tube with too much bias on it. It's cut off. And then with a strong signal on the grid, you can return the grid out of the cutoff area briefly, like little peaks in the signal. And that'll wake up the radio during those little clicky peaks, and that's what you hear. Does not seem to be volume dependent or tone control dependent. So I'm imagining that's either happening in the audio circuits or it's happening in the radio circuits. Well, obviously it's one or the other. Which one is it? I can't really tell from this. It is related to the tuning position. Something else I noticed. Let's put this right in the quiet spot here. I'm going to cut the power to the radio and just listen to what it does. Okay. Did you hear it? Hear it again? Okay, so when I cut the power, I'll do this once more. The radio goes from the quiet, clicky sound. As the voltage drains out of the radio, you hear shh. Listen. That's the moment, while there's still enough stuff in the radio for it to operate, voltages have dropped enough that the tubes come out of cutoff and it's actually operating. And same thing on the way up, there's a moment where it operates. Okay, that was quite interesting. You could hear the hums and various other things in the radio. Gone. So again, I think these are all indications of a tube in cutoff from improper bias. That's what I think that is. Why it's so tuning sensitive? That's an interesting question. I'm going to take a wild guess here. Yeah, that's my wild. I'm arguing with myself in my head, of course. What I was going to say was maybe there's a very strong noise signal there. It's producing a very high AVC voltage, and that's what's cutting the tube off. But of course, that can't really happen because once the tube's cut off, signal disappears out of the IF. AVC disappears, all comes back. Can't be that way. So as an AM radio, let's go to the other end of the band here. Now that sound, that ringing sound every time I turn the wheel. So what I believe is happening is as I turn the wheel, more and more string is being pulled out of here. Pulled out or released in. Exactly why, I couldn't tell you, because it doesn't seem to me that the length of the string should be changing. Could be because of funny angles with the string where it reaches the pointer, or just as you draw this part close to the pulley, the misalignment ends up consuming some string, changing the tension and pulling on these springs, and you hear that sound. Which literally the strings dragging across the plate here. It's a pretty good sound amplifier, really, for the spring effect there. Yeah, there's my light. Is that a problem? No, it's not really a problem. Observation. Sometimes you can see these getting pulled longer. So this is stretched out, almost maxed out in the space here that it's allowed for it. So another possibility is it's not actually stretching the string, but the string is being tugged, it's binding, it's tugging, and as I turn it, those tugs come and go and are released, and as they come and go, they yank on the spring here. I don't know. I mean, if this is changing size, that means the string is sliding and it's going to get cut here or somewhere else. Somewhere down the road. Okay, so let's try one of the shortwave bands. I just worked my way back on these buttons. My guess is this button is the highest band. Down, anything to be scared of? I don't think so. Hold on to your ears. Whoa, 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 almost pushed the radio right out of my shop here. Okay. Seems okay. We are on restricted power now. So if it's true, this is the band, then we're tuned up here top of the 19 meter band, about 15,360. 15. So let's go down. Bingo. That all sounded to me like AVC action on a strong signal, driving some tube into cutoff, and somehow the whole thing kind of balancing out in the end. I'm sure we're listening to Radio Cuba. This is almost certainly 15140 we're tuned to here. 15140, typical Cuba station. This should be here. Let's just fill it with my antenna for a sec here. Now you might say, "Oh, Jim, you reduced when you put the ground on, the signal almost disappeared. That's terrible. Take it off." But I think I've got better signal to noise ratio now. I just turn up the volume to discover it. I turn up the volume and discover it. And it's that AVC thing happening. Believe it? How about full volt? Maybe it's all because I'm running on 100 volts. It's possible. I'd say it's working worse. Give it lots of time now for voltages to sync to where the bias voltages to get to where they want to go. And of course the radio signal itself can be fading in and out, of course, which makes all this very challenging. Where'd it go? Where'd everything go? It's all gone quiet again. Ooh, it's really faded out. Oh. So, okay, so assuming all the fading is just the signal going in and out, it's not the radio itself. Seems like when it's on full power, it doesn't work quite as well. This is another indication of bias problems in the radio. But the fact is, it's working. Now let's go down. I'm going to assume the next button down will be this band. I mean, I'm still assuming we're at 15440, and maybe we're not on this band. So much fun not knowing what you're doing. Here we go. Okay, not so sure about that. Pretty quiet. This time of day we could pick this as the 11 megacycle 25 meter band. We should pick stuff up. Oh, I just hate the sound of that. Keep up in this area here. Can't seem to make it operate any differently than it is. So, a little quiet on that. Okay, let's go to the next one. Because this button is sticking in. There we go. Pull it out. So now I think I'm on this band, 9 megahertz, just below 10 megahertz. And it's possible to pick stuff up this time of day on this band. Yeah, the volume is up full. The volume and the tone, whichever one it is. She's dead. Okay, there's the string binding there. it's just dead. Okay, well, one more band to check. Ooh, I almost grabbed it like this. That's not wise. Don't do that. You don't know where your finger's going in behind. I even don't like having my hand on the chassis here to steady the radio. I don't like touching this with both hands at the same time. You really don't want to get a shock between your hands, because guess what's between your hands? Your heart. Now this is 6 megahertz at this time of day. Really nothing. But we should hear noise. We should hear noise signals. It's just dead. She's a dead. But not dead on the top band. So I think that also probably guarantees that I did have the band arrangement right here. This does go this way. We did hear it down here, and it was 15400, 15140. Well. Okay, let's do a couple other things. Let's take a look at the B plus voltage in here. Nice bright meter. Helpers. While we're doing that, let's listen to Cuba. Hello, Cuba. Cuba, calling Cuba. Oh my gosh, this thing's almost ready to fall right up. Okay, what happened just there? Everything went south. What happened? What happened there? Where'd he go? The string is past the bind point, so I can get all the way to the end of the dial. Gone. That's too bad. Okay, so my idea of listening to that went down the drain. But you know, you got to get experience with the radio. Can't know everything about it in 2 minutes. It takes time. It takes time for everything to surface. Talking about. Whoa. There. What about here? Here's one. Fit the meter in there. Perfect. Good. I try to measure the B plus in here. So one lead. There's a negative bus in here, which if it's the same as the other radio, I'm sure it is. The negative bus could be found I'm looking at the schematic for the other radio, but I'm pretty sure they're very, very similar. If we look at the volume control, the bottom is on the chassis. This is the negative bus here. Where can we pick that off? Well, in this radio, in the other radio, those capacitors were isolated from the chassis. In this radio, oh my gosh. It's just, I thought I convinced myself they weren't. Let's look again. The radio's operating, so I gotta be a little bit careful here. So there's one of the capacitors. Right, it's that guy. And it looks like it's mounted on an insulating piece. What's it look like up here? Oh yeah. I missed that the first time. It's actually an insulating piece. Okay, so so the negative bus will be the CAN part of this thing. And there must be wires going to it. It must be those black and red one there, right? Very good. So actually it's right across that capacitor. That's where we should start looking. Let us look. Right across there. Oh, scared me. 127, 128. That's not very much, but exactly where I am in the circuit there, I'm not sure. Let's give it full line voltage now, so we'll find out what it really is. B plus is... Oh, that's more like it. It's quite a difference, eh, between the restricted and the full. 300 volts. It's pretty healthy. Another place to look for that is on the plate of the output tube. Okay, let's check the, let's see, in this radio, again, this is for, that's for, actually for this radio here, but they're very, very similar. In order to bias the output tube, this radio supplies it with a little bit of a trick voltage here. Probably this one's doing the same thing. So this pushes, it's actually, oh, I'm looking at this wrong. I think I can look between the chassis. Well, I'll go ahead. I'm going to stick the voltmeter right on the grid of this output tube and to the chassis. That's cathode to grid. I might knock out what voltage is there, but let's try it. I think I found out this is a 10 meg input on this meter. That should give me some room for success here. Of course, I got to find out where's the plate. I'm sorry, where's the grid on the output tube, which is down here. That rectifier tube's really glowing there. I had these two tubes swapped in my head. No, I didn't. I got them swapped now. Correction. Output tube is really glowing there. Hey, now that's another sign of bad biasing. That tube looks like it's really going to town. How am I going to get in there? Get a little more light on the topic here. Since I'm going to chassis with one lead, let me use a clip lead and connect it, and I don't have to think about it after that. Just concentrate on one connection. Hey. Mysteries do abound. That's the volume right down. to be receiving again. Maybe. Shut this guy off. Calm him down. Let's go out. Switch it to AM just to quiet it down. Keep it working though. It's just like the other radio. Okay. Just like the other radio. Where's my... Needs a lot of cleanup. Make that work. Whew. Okay, let's just do this test here, and then I think my time is just about up. I got other things I got to do today. Okay, so grid on a 6F6 output tube is grid on a 6F6. Oh, I've got it written down here. Got it written down, but I don't know where. Okay, 6F6. Got to put it in gear here. 6EF, EF. So I'm just doing a preliminary test here. 6F6 grid pin 5. Just to get a sort of a preliminary look at things. Okay. Pin 5 on volts. Oh yeah, pin 5. Going in. Okay, there's the key. 1, 2, 3, 4, 5. Oh my gosh, really? Okay, so I think this is the grid here. Now this might make noise on the speaker. Should see a negative voltage here. You see that? Looks like negative nothing to me. Okay, hold that there. Tune the radio. Now I'm scared. I don't want to be touching things. Okay, so I may have made this voltage reading wrong. Reading it to the... Oh, for crying out loud. Oh yeah, I clipped this on, yeah. I made it wrong. Good guess, Jim. Let's try again. Let's try again. It's amazing. I'm getting a... That goes back to what my college professor said. The problem with these meters is they always get a reading. Let's try it again. Let's see what we get. I don't want to touch anything while I'm doing this. Wrong. That's the wrong one. This is the one. There we are. Now we're getting somewhere. Minus 1.8. Varying a lot. Around minus 3. And what does it require? Sounds a little low to me. 6F6. EF. Fixed bias, grid number 1, that's the one. Minus 16 volts. That's what it's looking for. You know, you're going to present the grid of the output tube with a fairly large signal. It's going to be 5, 10, 15 volts. You've got to have enough bias to clear that. So there's clearly. Let's get it. Let's kill this. Let's kill this. There's clearly a problem with the bias on the output tube. That's probably why we're getting those weird effects, a number of those different weird effects. Something's going wrong with the biasing of that tube. Could be a leaky capacitor, bringing in a positive charge towards the grid, or who knows? We don't know yet. But that probably explains the cutoff and everything like that. And now a little heat check. Nothing hot here. Excellent. By the way, that would cause a larger than normal current, steady current through the output tube, and cause it to run hotter than expected and wear out sooner than intended. Well, thanks a lot for watching, and I'm off to do. I got a busy day ahead of me. Hey, buddy. How you doing? You ready for a fun day? It's going to be a little sunny outside today. Yeah, it's going to be 10 degrees. Woo, like summer again. Isn't that great? Yeah, show us how big you are. What's that on your eye? Right. Oh, where'd you come from? You too. Well, that's the end of that.